Okay, so if I don't, please remind me so that I send you the link to it. Yeah, so now what we are going to do is to look at how data is stored in R, right? That's very important. When you are learning a programming language, especially for statistics, you have to know how data is stored because that's the primary source of what we do in statistics, data. Okay, and so we are going to talk about data structures and data types. Okay, so basically there are four structures. We can talk about five, but I usually don't use it, so but I'll mention it to you. So basically there are four structures. So A, we have a vector. Then B, we have a matrix. And then C, we have data frames. And then D, we have list. There can be E, we call them arrays, but I'm not going to treat it. I'll just mention it, arrays. Arrays, okay. So it means I have to change this to 5. Okay. Now, what are these data types? I'm going to use diagrams to illustrate. So when we say a vector, what is a vector? Yes. What is a vector? My dear friends, I'm asking you a question.
A vector can be described as an array of numbers with only one column.
With only one column. So what about when it is a row? What about one row? Is that how you define vectors in math? Okay, so at least you've said something. So in R, vector is of this form. Of course, you talked about column as well. So we can have a column vector and also a row vector. Now, matrix. What about a matrix? What is a matrix?
An array of numbers with columns and rows.
Okay, so here, for a matrix, we'll have basically columns and what? Rows. Now, data frames. It's also like this. It's also like a matrix, right? So it will also have rows and columns. List. It's also like this. It's also like a vector. So I'll explain the differences. Right. So a vector is one-dimensional array, right? Just like I have illustrated over there. Now, but the vector in R will contain only one data type. Is everybody okay? I'm going to also talk about data types very soon. But I can list them here so that we treat them together. Data types. So for data types, in R, we have one, numeric. This numeric may be integer, when we say integer, double, etc. They are all considered as numeric. Then 2, we can have what we call character. We can have characters. So characters is what you, in statistics, you term them as, let's say the scales of measurement. That will be under the nominal scale. Later on, we can take characters and turn it into a factor, which can be either nominal or ordinal, and so forth. So 3, we have logicals. So these logicals are what you mean by true or false. Okay. Then 4, we have factors. So factors are either nominal or what? Ordinal. I'll explain when we get there. Then 5, we can have missing values. In our missing values are denoted by NAs. 6, we have dates. Of course, date, time, date and time. What else am I missing? Yeah, I think that's all. Okay. So, if I have a variable called age, okay, each of us will have age, so you can tell me your age, you can tell me his age, and then I'll continue until I get to the last person. Okay. Now, the data I will get from this variable age will be what? Numeric, right? To be numbers. So that can be a vector, which is what? A numeric vector. Is everybody okay? All right. Now, I can also ask a question on your religion. Okay, then I'll get groups, right? That one, it won't be numbers, but it will be a sort of some strings that I'll put together, or characters that I put together to form a string. So I can write maybe Muslim, Christian, Buddhist, and so forth. Is that okay? Yeah, so this vector can be a vector of what? Characters, if we talk about religion. Is that okay? Now, what a vector will not be is when I have numeric and characters put together. Because I cannot have a vector or I cannot have a variable in which the variable gives numbers and at the same time is giving characters as well as answers. Is that okay? So that if there is no answer, I can put in a missing value. So age. Somebody did not, let's say, she doesn't want to tell us her age. Right? Yes. So the paper came, if let's say you announce papers for people to fill, and it's empty. So what do? You just put NA over there. Other than that, then you need to throw the entire data she has filled away. You may need some of them. So you have 30 questions. The person has filled maybe 20, but has left the age and then the salary out. Is that okay? Yeah. So you put NAs over there. Okay. But we cannot go and replace age with, let's say, a character, like A or maybe not known, something like that. So that's what we mean by a vector. So when we define a vector, it will contain one data type. And that data type may be numeric, it may be character as I have described, or the question may be something that you either evaluate it as true or false. Is that okay? If it is true or false, we term it a logical type. Are you with me? And then it can be factors. So factors are characters, right? But we can order them or let them be on its own. Like in that case, under the nominal scale. Okay, so factors are related to characters. So in raw form, when we collect the data, it's in characters. But we can use factor to do it such that it will transform it into either nominal scale or the ordinal scale of measurement. Okay. So it means that I can collect information on, let's say, the level, right? So in this class, we have level 600 and we have level 700, right? So what it means is that here, if it is levels, then it will be a factor with what? With order attached to it, right? Okay. But if it is just religion, we are not ranking religion, so it will just be under the nominal scale. So that's it. Okay. I've talked about missing values. Then dates. So for sometimes you are dealing with time series, right? If you are dealing with time series, then of course you can get the date or the time that and we can get date and time on that. If you type date and you click enter, today's date will appear on the screen. So that's also a data type. Okay. So now vector can be one-dimensional array of any of these. Is that okay? Any of these, but it can't combine them. Please, are we okay with that? Okay, good. Then we move to matrix. Matrix is a two-dimensional array. It also contains only one data type. So I cannot mix different data types in a matrix. The only time I can mix them is when I have a missing value. So missing value can go with any of these. Okay, that's accepted. But if I go and combine character with numbers, it will reduce all of it to the basic form, which is character. So a matrix will contain only one data type. Now, but sometimes when we have data, we want to be able to have variables that are numeric, variables that may be logical, and so forth in statistics. So you ask the person's age, their weight. You bring a weighing machine here. We weigh everybody. We check your height. But we ask you of your religion. So it means now we have variables that are, if you want to say quantitative, and some that are qualitative. Okay. So in that case, I cannot use a matrix to store them because a matrix must contain what? Only one data type. Is that okay? So data frame allows us to now store data or data that has different types. Okay. So that's the advantage of data frame. So, but it is the same as a matrix. The only advantage is that it can contain different data types, which means it can contain different data type, like in the form of quantitative and qualitative data. Is everybody okay with it? Okay. Then, any question before I move on? Now, if you don't have any question, then I move on. So if you look at list and vectors, they are the same. Their forms are the same because they are all one dimension. But the advantage of list is that's the highest or the top or the complex form of data structure in R, right? Why is it so? It is so because we can have any of these data structures within the list. Okay, so here I can input in a data that is one dimensional. The one over here may be what? Different dimension. Okay, this may be a matrix, this may be a data frame. And when I come here, it can even be a list within a list. So a list can contain any data structure as well as any data type. Is everybody okay? Is everybody okay with this? So that's the form of, or the structure we'll use in storing the data set. Okay. Now in R, we have most of our data stored as data frames. And it is so because of its flexibility in what? Accommodating what? Different data what? Types. Is everybody okay? Is everybody okay? All right, okay. So that's it. So now, if we understand this, we will now go to R and begin to implement these forms or these data structures. Okay, so now let's start with the vector. Oh, so and then the array is also one dimensional. Okay, but usually it is used to store just the numeric, or it can also store one data type, but it can also contain matrices and matrices, so to speak. Okay, within it. So it's like a vector. But within, it's just like a list. But that one is only what? Matrices and so forth within it. Okay, so vector. So how do we construct vectors? So A or one vectors. Now, so we create vectors with C. The function C, replicate, and we can use this, any of this. Okay, so let's see how we will do them. So the first one, let's say age. Age, I can use C. Okay, so let's assume I ask 5 people, what are your ages? And I got this. So these are the ages of the 5 people. So I use a C. If you don't understand anything we say in now, what do? You question mark it, right? Okay, so we can question mark C. And it tells us that C is what? Is to combine values into what? A vector or a list. So we can use it to create a list as well. The C command. And this is small letter C, not capital letter C. Okay. So we do this. What do you see on the environment? Age is what? Numeric, yes. And it is made up of what? 5 objects or ages. Okay. Now, it means that we can also get the religion of these 5 people. And these are, let's say, Christian. No. The next one is Muslim. Maybe. You see the characters, I am putting them in what? In quotation marks. Is everybody okay? Yeah, so, but the numbers need not. So if I have a number and I put it in quotation marks, it becomes what? A character. You can use the machine, okay? Then after that you can email it to yourself. Okay, next, maybe the next person is Christian again. And then maybe the last person is a Muslim. Okay. So you see, religion is not here because we have not run it, right? So I ran it now. I see religion. What does it say? It's a character. Is everybody okay? Okay. Now, we can also list. So we've now seen how to use the C. Now, what about the column? Well, we use the column to generate vectors, numeric vectors, okay, so that we have a beginning point and an end point, and then each of the vectors within it is just a one-step, let's say, integer, either below it or what, above it. What do I mean? Well, if I say 1 to 10, it means I want to display the numbers 1, 2, 3 up to 10. Okay. So if I run this, you see 1, 2, 3 up to 10 is displayed on the screen, which means I can also, let's say, name this as number dot, let's maybe number dot, what should I even put it? Or just number. Okay. So you see, number is now, it's what? An integer. Is that okay? Remember I said integer and numeric, they are the same. It's just the way R stores it. Okay. Okay. So that's how you use the column to generate what? A vector. Now we can also, I can add sequence to it. So remember this, I'm moving in step of 1. I can even start from 20 to 1 as well. That means I'll move what? Backwards. Is that okay? So when you use the column, you are moving in steps of 1. But what if we want to move in step of, let's say, 0.5 or 0.1? We cannot use the column to do so. The function we will use is called SEQ. It's the short form of sequence. So SEQ is sequence. So if we want to say it, we will do question mark sequence. And it tells us that this is what? Sequence generation. So how do we use this? Well, if you come down here, you will see it. So we can copy and paste here. So if you are generating a sequence, you must move from a value to what? To a value. Then by is what step you want to move in. Okay. If you don't provide, it will just use the range divided by the what? The sum number of elements in there to -1 to get what? To get the by. Now length dot out also gives, let's say, how many divisions should I do? Okay, so maybe I want to move in equal spacing from 10 to 20 in steps of maybe 40. How do I do that? Okay, so then length out will then be, I want to generate 40 equally spaced intervals between 10 and 20. Then I can say that I want to move from 10 to 20. Length out should be 40. And it will generate 40 divisions within 10 and 20. So that's it. Okay. So let's try one. So we move from 1 to 10. We say length out. So let's say length out is 20. Okay, we can delete this. If I use length out, I can take by off because I'm just telling out that generate 20 observations from 1 to 10. Okay, so let's see how this will come out. Okay, so how many numbers? You have 19 and what? 20. Okay. Now, the alternative to buy will be, let's say, if I want to move, I can move in from 1 to 10 by, let's say, 0.05 or 5. No, I said 0.5. Okay. Like that. Okay, so this one we will move from 1. The next value will be what? 1.5. The next will be what? 2. And so forth. So that's how this works. Now, what I want to say is that if I put anything here, this will be what? A vector. So if we come here and we check at our environment, you will see that IND is numeric, right? And it's a numeric vector. So we can use any of these to create what? A vector. Yes.
Please, can you go over the length out? I didn't get it.
So the length out is the number of objects or the equal spacings you want to have. So if I say 20, then I'll generate equal numbers from 1 to 20, but I want to get 1 to 10, but I want to get 20 of them. Yeah, that's how it is. So you need to provide one of them, right? Not all of them. One will suffice. If you use length out, you are okay. If you use by, you are okay. If you are using the by, then you know how your steps should be. But if you just say that I need 100 observations from this interval, then you leave it to how to now generate what those numbers will be. Any question? Okay. Then we can also name the vectors. How do you name the vectors? Well, How do you do this? Well, you use the function names. So remember that we have those five ages, right? So we can provide the names of people whose ages we took. So maybe the first one is Abba. Remember, Abba is a name, so I put it in what? Quotation marks, right? Okay. The next one, maybe Amma. The next one is Ali. The next one is Aku. And last one, I want 3-letter. Name with 3-letter. Esi. There was not enough gender balance. Okay, so I name age. Now, what do you see in the environment for age? It used to be numeric, right? Now, there's a more qualification for it. So, name or now. So that means it is name. Is that okay? Now, when we name it like this, we can call them. So, how can you tell me Ali's age? How do you tell me Ali's age? Well, if I put all this here, Ali is number what? Number what? 3, good, okay. So now I move to subscripting. Subscripting with vectors. So what this means is that how do we retrieve observation from a vector? That's all. Now, so 2 ways. Or 2 methods. A or I through the position. So in this case, since Ali is in 3, I put H3 and I run it. What do you see on the console? Is Ali the 3rd person? Yes. Super. So we can use the position to retrieve objects, right? Now, not that alone, within the position we can input a vector because we may want to select more than one ages, right, of people. So for example, if I want Ali and Ac's ages, then what do I have to do? I need to call age. Okay, then I use the same vector. What are the positions? 3 and what? Is it 6? 6, like that. 5, okay. So we get Ali and AC. Right here. So, So when you want to use a position, you just have to note the position of the object. Okay. Now, I. Please, you stop me at any point in time if you need to ask a question. Okay, so we can use the name. So instead of putting in age 3, I could have just called the name of, the age of Ali. Is that okay? Now how do I do so? I'll just write age, the bracket, the square bracket. Then I put the name of Ali there, but the spelling must be right. Other than that, you will get an error. Okay, so the spelling must correspond to the name that we've done over there. Okay. So this is what I mean. If we want Ali, so we will call age and then put Ali's name in this. So here, wherever Ali is, should be retrieved. Similarly, we can get Ali and the last person, the one on the 5th is what? AC. Yeah, I cannot do this. Let me do it. In now, you have to make mistakes and correct yourself. Now, do you think I'll get what I'm looking for? So let me do it. We'll get an error. Then we. So before I run it, I know that I'll get an error. Can you tell me why?
Yes, because just like we did for the first type where we did the positions,
Yeah.
you have to put it in a bracket.
Yes, good.
And
Is that
they're
it?
combined.
Good, yeah. That's exactly what. We need to put this, because we have to pass it through as a vector. So we need to put this in bracket and put the C, the combined, over there. Once we do that, we should get. Any question? So we will extend this to these guys as well. Matrix, data frames, and that one. So for lists, because they are identical to vectors, we now know how to retrieve an object from a list. All we have to do is to call the name of the list and put into bracket what? The position. And we can use the names as well, just like we've done over there. Now for these two guys, matrix and data frames, because they are rectangular, if we are using the position, then we need to do what? We need to get the rows as well as the column. Is everybody okay with it? Okay. And these two, that's how we will do it. So that's it. And these are very important, all the things that we are doing. Later on, when you are doing your thesis or you are at the workplace, you have a data from people. Then you want to sort or retrieve some, maybe they're giving you a region for the whole of Ghana, data on the regions of the whole of Ghana. You want to retrieve, let's say, Beta Accra regions data from it. How do you, that's what we are trying to do. That's why we are going through all this, to know how to get data from it. Okay. So very soon I'll show you, I'll show you a data setting now, then we'll start retrieving some of it. Yes.
At one point you use the square bracket, at another point you use the parentheses.
So the parenthesis is to create the vector. Yeah. If you are saturated, if you want to retrieve, it's a square bracket. But within the square bracket, you must provide either a position or what? The name. Is that okay? If I have more than one, I cannot be listing them. That's why I committed that mistake. So you need to put them as a vector so that they go in as a vector, and then it will start retrieving them. Any questions so far? All right. Okay. So that's it with a vector. Okay. I think one of them, there was replication that I did not do. But I can explain to you, and then you see, sometimes, let's say I want you, let's say I have 2 or 20, 20, 20, 20, okay, within this. I don't need to, if I'm typing it, I don't need to type all these 20, 20, if they are 1,000. So it means repetition, so replicate is repetition. So what we can do, we can create a vector if it is the same as this, rep. So that will be replicate 20. How many times? I think times is equal to, let's say, 4. So this means replicate 20 how many times? 4. So it should be 20, 20, 20. Yeah. So that's it. Let me check if it is times. So that was to be done somewhere here, right? Not naming, but here. Before here. With replicate. So here, if you, as I said, any function, if you want to see how it is done, just question mark it. So replicate is all. Replicate elements of what? Vectors and what? List. Okay. So if you want to do this, as I said, you do replicate. If you come here, so yes, it's times, right? Yeah, so replicate x is the value. So we can say 20, and then times, we want how many? 4. So if I do this, I'm going to get 20, 20, 20, 20, 20. Now, let me do one more and ask you what you think this will be. I have C, or 1, 5, and 9. And then I say this times should be 5. What do you think will be the answer? The second one. We have 159. We want to replicate it 5 times. What will be the result? You have. Is it 11111 or 159? 159, yeah. So what we have provided is the repetition. That is, so we have 159, then 159, 15. How many times? 4 times, yeah. But if we assign this will also be what? A vector. So that's what I skipped over there. Yeah, so you can. So we are done with vectors. Any question? Can I continue?
Say I'm having an error.
Okay, what does it say?
Error, unexpected.
Unexpected.
Then inverted or something like that.
Yes, so yes, so check your parentheses. How many do you have? So you see, one of them is you must have the even number of parentheses on the same line. Now you have 3. Yeah, so now it should be. And I think you have, the top there you have a problem there. That's why it is also showing you that time. Yes. Any question? Yes. simulation where let's say then you come and take your result, but it's only appearing one. Yeah, so programming is quite, you have to be very meticulous. Other than that, you can spend your entire time doing it for months, and now you are doing your result, then you have to come back all over again. So I have done work in this thing, so I know how challenging these things can be, especially with simulations. Because you can do it, you tell it all, then you realize you made a mistake. Which you have to come back, and also whenever you have to send anything, you must. So when you are doing program, you do it, then you leave it for some time. You come back and then you assume you don't know anything, then you start all over. So that helps in what? Correcting some of the mistakes. And what happened here, I can demonstrate it so that you see what I'm talking about. So it was like this. You see, we got a result. Yeah, so the result is just one repetition. In some cases, you should have given us, if it gives you an error, then you're okay. But this one, you can run with it. Okay, if you are not interacting with the program, that's what I was saying. Because, I mean, when you are doing simulation, you cannot be interacting with you have to leave it for it to run, and then you get your answers. So if you put this in and you don't check, all your answers will be wrong. Yeah. Okay. All right. Okay. Any question? Okay. So that's a vector. So 2. We now talk about matrices. So matrix, we said is what? 2-dimensional array, right? It's a 2-dimensional array. Okay. Now, to create a matrix, there are about 3 different ways you can use to create a matrix. A 2-dimensional array made up of the same data types. Data type, I should say. So how do we create matrix? So how to create a matrix? So A, we can use matrix. So how do we do that? Well, in this case, you need a vector, a long vector, and then you break it into what? Columns and rows. Okay. So let's say we have a we want to select. Did we talk about sampling the last time? Did I introduce the function sample?
Yes.
I did.
Yes.
Okay. So let's sample 20 observations from 1 to 90. I think we did an example on Lotto, right?
Yes.
Good, okay. So now we want to sample 20 observations from 1 to 90. So how do we do so? So let's say today our Lotto 20 is that you have to sample X is 1 to 90. Then the size is equal to 20. Do we want to replace it? If you want to do sampling with replacement, which means one number can appear more than once, then we need to put or replace it equal to true. So replace is what? It's a logical what? Data type. Is everybody okay? Yeah, so we can change this to false and then it will be, yes, it's to true.
So
Yeah.
Can we have a situation where we want to repeat some numbers? but we
Repeat.
want- Yeah, we want to repeat some numbers,
Mhm.
but we want each to repeat, say, twice.
Then you are putting a condition on your sampling.
No, not the sampling one, before the replicate one.
This one.
The question is on the replicate.
The replicate. You can. So I can put replicate within replicate. So because you need a vector to do it. So that vector, if let's say I have 1, 2, then I have 6, 6, 6, 6, and then maybe 10. I can create my vector C, and then I have 1, 2, then I have replicate 6 4 times, then 10. Right? That will work. So that will expand, and then I repeat that maybe 4 times. So you can do it. Okay. Please, are we all okay with this? So please look at this. I said if we want numbers to repeat, that stand a chance of what being repeated, we will put this logical argument to true. Okay, but if it's Lotto, you don't want the same number to appear on more than once. So we leave it like that. So let's do the Lotto. And what will happen? Are we going to get the same numbers? No.
No.
Did I show you how we can get the same numbers? We did.
Yes.
We did. Okay, what did we do? We set the seed, right? So maybe this one we want to create the same set of values. So let's set the seed. Let's say we use 404 as our seed argument. So we do this so that all of us will get these numbers. Is everybody okay now? Can we move on or you are still typing? Okay. Okay, please hurry up. Display your Lotto and let's see whether you get the same one. Have you gotten the values? Is it different? It's the same. Yeah. You have to run it. You've assigned it, but the values are 47, it's different. I think you did not run the set.c. Run the set.c. No, it won't show because what you have done is assignment C.
So the set of C is here.
Yeah, so run it. And then run the loop. It's okay, you can put it anywhere and run it. Okay, so you see it's the same. The values are also here. But if you want to display it alone, you must highlight Loto alone and run. Yeah, so highlight only Loto, right? Good, yeah, and then you run. Alternatively, you can put all of them inside parentheses. So that one, it will do the assignment and also display.
Okay.
Because are we all gotten the values?
So the parentheses can, should it be the square?
No,
Or
the parenthesis is a round one.
round one.
Some of them will get yeah. So now we want to we want to create a matrix now. So see, we have now a long matrix made up of what? 20 observations. What we are going to do is to create a matrix. Then we'll have week 1 numbers, week 2 numbers, week 3 numbers, and week 4. Is everybody okay? So every week, the first number that came, the second number, so that's what we want to do. So we want to do something like this so that week 1, we will have numbers 1, 2, 3, 4, 5. Then we go to week 2, 1, 2, 3, 4, 5, week 3, and so week 4, then that should be 20 of them. Okay. So how do we create it? We'll use the function matrix. So let's do question mark matrix. So question mark matrix. So that's the first thing we talk about, matrix. So what does it say? It says that matrix creates what? A matrix from what? A given set of what? Values. So we need to do that. Okay. So when you come down here, you will see the usage of the matrix. So it's like this. So you copy that and then you paste over here. We are taking our time to do this because if you are doing MPhil statistics, you have to have mastery of, like maybe if you are doing applied statistics, it's different. Because there, you just need the data to work with it. But for you, that will be implementing simulation studies. You do estimation, and you need this. Otherwise, it will be difficult to understand the numbers. That's why we are taking time to go through this very well. So please make sure that whatever we do, you really understand the concept. Okay. So now the data is what we have already, which is the Loto, right? Okay. So Loto, we will replace instead of NA. Remember, NA is what? Missing value. Good. We replace it. Then how many rows do we want? It will be 5 rows. Good. What about the columns? 4, yes. But now we just need to specify just once. Once we are given the data, 1 is enough because ours has 20 numbers. You want to form 5 rows. So what will be the column? It's automatic. But if you put it there, it's also okay. All right. So 4. Then this argument is logical. Okay. Now, if we say that by row is false. What? Remember, we are coming to fill in numbers. So we can fill in the numbers as they 75, 57. So in that case, I'm filling it what? Row wise. I'll do this row. When I finish, I come and do this, and then and so forth. Then we could have also gone through this way. So when by row is false, it means we must go through it by column. This is very important. So in that case, 57 will be here. Then we'll go on till we come to this side, and then that side, and then that side. So they are different. If you are doing this and you are not careful, if it is age and weight, somebody's age will now become somebody's. That's how it will. So that argument is very important when you are forming a matrix. Please, are you okay? All right. So now we need to decide which way we want to go. If we want to go column wise, we will leave it like that. But if we want to go row wise, we do it by row is what? Through. Which one do you want us to use? Column wise. Okay, so we leave it like that. Then the dim names, we can provide the names of the rows and the columns with this argument. But I would rather we do it when we have finished creating the matrix. Yeah, so I'll take it off. Okay. So let's see how this matrix looks like. And it's exactly what we want to do, right? So if you display it like this, that will be, but I need to save it. So I'll say week Lotto. So I will now save it as what? Week Lotto. So week Lotto will be of this form. Okay. But now what we want to do is to name it week 1, week 2, week 3, week 4 as a column. Okay. There we are 1, 2, 3, 4, 5 as the rows. If you want to name it, you can also do so like that. Okay. Okay, we can do it like that as well. Yeah. So Monday, Tuesdays, and so forth. I think that is days. Do we have as a week? That's a long time, I think. Yes, weekdays. You can actually try weekdays. Let's see. Yeah, there's a way to get, let me see, weekday 1. Okay, let's, weekdays. Okay, so it has to be there. Once you provide the date, then you can get the week day from it, and then the month, quarter, and so forth. So let's just do Monday, Tuesdays. Okay. So how do we, what we need to do is naming rows and columns. Okay. So for the column, we want weekdays. So we'll just say call names. Call names is to name columns. So call names of week Lotto will be, you said that Monday, Tuesday, Monday, then Tuesdays, then Wednesday, then Thursday. Remember, we are putting all this in what? Quotation marks. And Friday. So once we do this, and we run it, no, it's 4. Yeah, they are 4. So maybe we should take Monday off or Friday. Yeah, let's take Monday off. Yeah. So that's, if you see this error, it tells you that the dim names 2 not equal to all. So the dim names, the 1 is for the rows and then 2 is for columns. So it is telling you that the dim name for the columns is not equal to the array length. Yeah. So now we can do it and it will work. There. And then we can now display the lotto numbers, and there we have it. So that's how we'll name. If we want row, we will just say row names. Rather call names or row names. So if you want to, yes. We can name the rows first row, second row, third row, fourth row. So, please, have we all saved it? Weekly Lotto. Have you named the columns? Okay. So, let's all name the rows. We are naming the rows. The first draw, second draw, third draw. Just use 1 ST, then 2 ND, 3 RD. Is that okay? Do you understand what I say you should do?
No.
We've named the columns. Now I want you to name the rows. But row 1 will be first draw. Row 2 will be your second draw. Row 3, third draw. Row 4, fourth draw. Row 5, fifth draw. Is that okay? Yeah.
We have a challenge.
Wait. So did you know? Yes. So have you created a weak one? No, you did not name it. You just what you did is what has appeared. But you need to now assign it to the name weak loading. So how is telling you that it cannot find anything called weak loading? Yeah. So copy the weak loading. You copy, and then the next the line preceding it. Yes, no, go to the first one. That's what you are naming as weak loading. And that's the line one. Yes. Where you created a matrix. So your matrix, you did not name it. And then you were calling it. So you have to, the assignment stage. Good, yeah, and then you run it. So you must have the weak lotto here before you can name it. Good, okay. So now you can name it. Run the name, yes. Put it anywhere, where it is something. Anywhere to know. You have the weak lotto, but you don't have the name. Yes, it's okay. Then you run. Good, yeah. So now you can display the weak lotto to see. No, you have to.
highlight it.
Yes, and run again. Okay. Yeah. Okay. So now let's name the rows. So what you can do, you can just copy this. You paste. So instead of call, this will be what? Row. Then the first one we have first draw. I can just copy, paste. So when you are doing these things, you have to, you don't have to type everything. If you type so much, you even make mistakes. So second, then I change this to a third. I change this to what? Fourth. And then lastly we have what? Fifth. Fifth draw. And then I run it. So now if I display week lotto, there it is. Yes. Okay. Yes.
So at the point where we started the matrix,
Yeah.
the function that we got had name. And
Yeah,
then
we could have
deleted it.
done this in there as a list, but it makes it too complicated. So I usually don't teach it that way. I want you to create your matrix and then you name it. Now you can put all this inside the creation of the matrix at a go. So if that is okay for you.
So how will it look like?
So dim names will equal to list, and then you have the first one as the row, column names, and then the second one. Sorry, the first one as row name, and then the second object of the list as column name. Yes. Okay, let me. Whenever you see the plus sign, whenever you see the plus sign, whatever you do will not appear, because when there is a plus sign on the console, it means that you have opened either a parenthesis or a curly bracket or a square bracket and you have not closed it. Okay, so I will be looking for what will close what you have opened. And if it's not come, everything you run will be over there, but you won't get result. It's running, but you are not getting result. So if it comes to that, you click on the console, then you press escape, then it will escape from the loop, and then you have your prompt. So click on the yes, and then press escape. Good. Then now you have a prompt sign. So you can repeat whatever you wanted to. What number of what was that? So you have to keep selecting. Yeah, but you see row name, and then there is a bracket. What row names are you giving? No. Row name of what? But the week is over. You don't get it. So that's why you are getting it. So copy what you have over there. The assignment from that to the assignment. Good. So you cut all of that. you have assignment, no, the next one, row 29. 26, sorry, 26, there's a mistake there. The same mistake. You have C, you have, so comment it out. Comment. Now come and run your row again. You're getting something. The same thing, row 29, so you have that problem. Highlight it. Highlight it. Yes. Yeah, look at your C. It is not, there's one, there should be a parenthesis beginning. You have to always work within the parenthesis. Other than that, you will have it, so now do it again. Okay. So you have to, when it gives you the parenthesis, you must work within. Don't delete anything. You put a cursor in, then you do whatever you have to do. Yes.
You have a challenge. If you type it, it's wrong.
Yes. No, you have to put all of them in quotation marks. It means look at your fourth door. You did not close the quotation. No, you just run that one. No, it has selected only the TV4. I don't know how it works. So now you can display the weekly printer again. Yes. So now you have. Yes. Because we had the weekdays, Monday, Tuesday, but the columns were 4. That's why we're making 19. Any question? Is everybody okay? So that's how we name our rows and then our columns. Is everybody okay?
Sir.
It's the same thing that will be done for the data frames. Yes.
Yes, so assuming that we've named them and we want to edit them, because my own, I didn't write it. I just wrote it in characters.
Okay.
For first row, second row. So
Yeah.
assuming I want to make that change to look like this, what
Yes.
do I do?
You go to the what you run and then change it and rerun it.
Okay.
Any question again? Are we okay? So can we, once we know how to name it and so forth, and how to create it, okay, we can then go to how do we subscript with matrices. In other words, if I ask you, show me the Wednesday lotto numbers, how are you going to tell me? Or if I want all the numbers that were drawn on the second draw, how are you going to get it to me? Or what is the second number that was drawn on Friday? These are the things we are asking of what? The data set. So that's what we mean by subscripting. Is that okay? All right. So subscripting with matrices. Okay. So here, when we want to subscript, we need the name of the matrix. It's like matrix. Okay, then we have I, J. So here, I is the row number, row numbers, where I is the row number, and J is the column. So it is either number or numbers. Let me put it in. Okay. So, first of all, I said, what is Wednesday's missing number? Don't go and stake it. That's like Wednesday we did it in class, so you use your school fees to go and stake. Okay, so 2 is just like we did. We can use or the position or what or the name. Is that okay? So if we are using the position, because Wednesday is a column, we will leave. Remember that what I said. This. We get the name of the matrix, and I is the row names. But we want all rows, right? So we'll leave that part empty. We can also write 1:5 because they have 5 rows. So that it will be 1, 2, 3, 4, 5. But if you leave it empty, it means you want all of it. So because we want Wednesday, what we are going to do is to say that Wednesday is what? The second column. Now, alternatively, so or we could have just called this week data, and then instead of the number, what do we put there? The name, isn't it? And in that case, it's what? Wednesday. So any one of them will give us the same result. And it's just like what we did previously. So you see Wednesday result is there. We had all 40, 66, 10, 59, 54. Now if we run this one too, if you are doing that, remember the name must be yours, must be the same. Is that okay? So that's how we'll get Wednesday one. So with this, you can also get what? All the first draw. Remember, we can get 2. We can get it in Wednesday and Friday. In that case, what do? We will call the names of Wednesday and Friday and put it, instead of Wednesday alone, we have a vector of Wednesday and of Friday. Yes.
Please, can you go back what you said about the comma?
Okay, so the key is over here. So if you are subscripting, you have the name of the matrix, and then you have the square bracket, then we have I, j. So I is the rows you want to select. J is the columns you want to select. Now, in this case, I want to select all rows. So I'll leave before I as empty. You can write 1, 2, 3 up to 5, but that's unnecessary, so you leave it empty. Then the J, I only want Wednesday, so either I put Wednesday or the name. Is that okay? Yeah. Okay.
Name in terms of the position.
Yes, the column name that we want to retrieve.
Okay.
It's just like that of the, remember the vector.
Draw or second draw.
No, that is row.
Wednesday.
Pardon me?
The column name is Wednesday.
Yes, the column name is Wednesday. Yeah. If we want row, let's say we want all the first draws, which we can do so. It means that we will, when we call this, we will call, so Wednesday, let's say first number drawn. Then in this case, I'll call this, I need all the columns, but I want the first draw, so I put 1 day. Okay, so when you do it, it's Tuesday was 75, Wednesday was 40, Thursday 26, Friday 62. Can we move on? Can we move on?
Say,
Yes.
ask what 115. You are
Yes.
using the square bracket and not the parentheses. Why?
We don't use the parentheses for subscripting. The parentheses are used to create or get an input. When you use a square bracket, it means you want to retrieve something.
Okay.
Yeah. Any question? Okay, please, can we move on? So let's look at a data set that is stored in R as a matrix. Okay, so data, a matrix data in R. Okay, so let's do question mark state dot x77. So look at this. So it is in the data set package. State is in the data set package. And it is US facts and figures. Right? So what we want is this, there are a lot of them, several of them. But we are interested in state.x77. Right? So if you look at it, it consists of the state ABB, which is character vector of two-letter abbreviation of the state. State area, numeric vector of all state areas. State center, list with component named S and Y giving so and so. So let's look at the dimension or even the structure. So structure, remember we've talked about, we are still on structure of data. So to get the structure, we use str. So let's copy this and put in. So you see, it says that state.x77 contains what? It contains what? Numeric observations. Is that okay?
Yes.
You see, we have the square bracket. We have 1 to 50 before the comma and then 1 to 8. So what can you say about this? From what we have done, 1 to 50 means what? It has 50 rows. So you have 1, 2, 3, 4, or 50 observations. Good. And then how many variables? 8. Because when we create a data, the variables are the columns, and then the rows are what? The observations. Okay. So if you look at this, and it is giving you the names. So the dim names. Remember, the dim names are what? The rows and column name. So the list we have what? Alabama and so forth. Those are the row names. That gives you the state. It's like in Ghana, the regions. And then you have the other one, the columns as well. The population, the income, illiteracy, life expectancy, and so forth. So those are the variables. Okay. So we can display this data on our console. To do that, you just, okay, even before that, we know this, another way to look at this, if you want dimension, you use dim, right? So the dimension will give you how many rows, how many columns. But we know that already. It's what? 50 by 8. Yeah. So let's look at what that will give us. 50 rows, 8 columns. Okay. So we want to see what state X77 is. So there it is. So this is the data. Remember, and this is you see, all of them are what? Numeric. That's why it is stored as what? A matrix. All the 8 variables are numeric. So you see Alabama, so and so. So now we can ask you to find what are the data sets for what? California and Colorado. What does that mean? It means that to retrieve this, you can retrieve all the what? All the data set, population, income, illiteracy, life expectancy, all of them. Okay. If I want to get the population and income data, it means I only need what? The first 2 columns. So that's why we went through that exercise. So if I, let's say, give you this data and I want you to study the relationship between population and income, then it means you need to retrieve what? That first 2 columns and be able to do your plot. So this is a typical data that is stored as a matrix. So later on we'll be checking which countries have life expectancy over 70. So that means we can use a logical argument to check which one are over 70. Then we select them. So all those things are. Or they have murder rates above 15. If they have murder rates above 15, you can find that as well. So let's see. Just do a simple exercise. Let's see. Can you select the data for Hawaii and Florida? What is the easiest way to do this? If you start using the numbers, so each of them has its advantages. So it means that if I give you a data set and it has 10,000 numbers, you go and be checking in an examination, you won't even finish. Do you get what I'm saying? Yes. So in this case, you need the names to select it. So that's why we went to. So please select the names for, the data for, I said what, Hawaii and what, Florida. So you need to call the name, you bring the square bracket, and then you need the names of those. This one. Are you done? Okay, good.
We are trying to get the data in this form.
In which form?
The form display of the form.
Oh, you just highlight it. But because there are many, if you want to display all, you have to shift it to the other side. Other than that, it will be like that. Okay, so what I asked you to do, it was all Hawaii and what? And Florida. So we will call state.x77. Remember these ones, they are what? Rows. So I'll leave the J column empty, and then I use what? Hawaii and Florida. Like this. Okay, so then I run this. So you see, we've retrieved only Hawaii and Florida data. Okay, and the other one we wanted to retrieve was population and what? Income. Yeah. Okay, so that, because that one is closed, we could use 1 and 2, right? Or we can also bring in population and all. And so it depends. Whichever one is easier for you, you use. So 1 and 2. But if you work with this, it's far better because then it is specific. This one, I need to know the data before I know that 1 is population and then 2 is this one. So that's it. Okay. Oh, sorry. It has to be after. Like this. Like this. Okay. So I can name this pop income. Okay. And I can check the relationship between population, even though we are yet to do our plots. But I can plot pop income, and there we have it. Because it's a matrix of 2 columns, I can plot it quite easily. Okay, so if you were asked to study the relationship between what? Income and population, this is what we will be having, right? That's our, then we'll start plotting. Any question? So this is the reason why we are doing all this. At the point when we have data, we may need some specific variables or observations from it. What do we get? Any question? You asked it? Okay, hurry up. Yes.
If we have our data set already, we want to change it, like we want to transpose. What do we do?
If you want to transpose.
Yes, so as you
Like this,
that,
you want
change
the
the position of the states to where we have the income and population
Yeah, so you just use T. T is transpose. Small letter T is transpose.
T of like the.
Yes, small letter T of into bracket, into parentheses, then the data. So, for example, the pop income, if I use T on it, it is going to change the rows to columns. So, I'll get now a 2 by, you see, 2 by 50 matrix. 2 rows, 50 columns. Any question? So can we move on? Shall we? Oh, you are still digesting it. So that we go back and learn about digestive systems. Okay.
So please, can you go over the pop income?
Oh, that.
This pop income.
So I stored that my data, which is the population and the income. I wanted to check their relationship, so I stored it as in a new variable called pop income. Yeah, and then after that, I plotted it to see how they are related. And if you look at this, what will you say?
You don't see any relationship, any direct relationship.
Oh, there is. There is. There will be some positive relationship. If you look at as the population increases, you realize that it's not that strong. Just a minute. Let me walk to my office. I took it that I was coming with it. Sorry about that. Okay.
Say,
Yes.
so because we want the population and the income, that is why we have 1:2.
Yes.
So if you want illiteracy,
If I want illiteracy, then that's what I was saying, that because you can use numbers and also the names. So if I want illiteracy, it should be 1 and 3. But you want to be going through data like that, it's not advisable to be using the numbers. Unless it's too obvious, like maybe 1. But if I want, let's say, you say illiteracy and what?
we want to add illiteracy to it.
Oh, then I can also do 1 and 3. So in that case, if I display, let's say, head, you can check the first few observations using head. Okay, so the first 6 observations, it means I have now 3. If I want the last values, I use tail of pop income. So I'll get these Z's or, yeah. Yeah. But, the best thing will be to use the names. Yeah, the names is better. So in that case, or what you need to do is to just call this, and then you go here and copy. You see the way I don't always type. Okay, when you type, you make mistakes in now. So usually you just this, and then I can now put each of them in quotation mark. In that case, you avoid those what is it? Yes, errors of either because this one, the names have to be written correctly. Right. Other than that, there. And now if I display pop income, I plotted is the same thing. You get it? Yeah. So that's it with this. Okay, so that's it. Now let's move on to talk about data frames. So this we will finish early. Now, how many observations? We have 50 observations. Okay. So now what I want to do is that I want to create a variable which gives predominant religion in that state. Is everybody okay? We are still using this to learn about statistics, how to do sampling and so forth. Okay. So you remember we talked about religion. Yes, we have created a vector or not, religion. Okay, so what we are going to do now is that we are going to select religion for each state. So I want 50 observations. Okay, but I now have religion, and religion is 5. So what do you think? How can we sample to get the 50 observations? Replicate. Replication will not be sampling. One way is to replicate it, but that will just be repeating. Okay. We want to randomly assign religion to each state. What should we do?
So we set a seed.
Why are we setting seed? You want all of us to get the same thing.
We use sample.
Sample, okay. Do you get the question I'm asking? We want to create one column called religion. Then we are going to give religion to each state. So how do we do this? We have 5 types of religion. We want to randomly assign religion to the state. What should we do? We sample, yes. How? 1 to 50. Yes. We should try. You have the types of religion, they are 5. You want to be able to do that, so that Alabama, maybe you assign Christianity. You assign the Vermont, you assign the Florida, you assign. How are we going to do
So
it?
I think you can use logical statement.
Logical statement. Okay. How are we going to do that?
So when we put a logical statement, for example, we pick one state. If we want to name it, we want to give it Christianity.
Yes.
So that will be true. Then comma false.
But I will not give us Christianity. You want to be able to do this so that if I now type Florida, Florida will have another a religion. Yes.
Not the same religion, but different.
Yes, we want to do it random so that we are not biased. Yes. You want to try? No, you should. You are thinking of it. This one is Sesame. Sesame, you don't think. You just write. Whatever is coming, you just, yeah. Then you go on. Yes. Remember I talked about something with replacement?
Yes.
Yeah, because you cannot do something, the religions are 5. So how are you going to do the something and you don't replace it? So finish in 5.
So you add a true
Yes.
add a true
Replace.
within that function.
Function, good, yeah. So the replace function should be true. What will be the X? You get what we are, so add data frame, so religion. So I would say state religion, right? Okay, so let me say religion, randomly assign religion to states. So what are we going to do? We say sample, right? You can go and check what is the health path for sample. So if you come to sample, X, what are we? X is what? What you are sampling. What is it? What are we going to sample? The what?
State.x77.
Are you sure? That's not what we are sampling. The religion, good. So X will be religion. Okay. What else do we have? The size. What will be the size?
1 to 5.
What is the size? At the end of the day, how many religions do we want to get? 50, good. Or you can even say that is the number of rows for state X77. So we have n rows. When you are programming, you avoid using numbers. If you use numbers, it means that anytime you change your data, you have to go in and change all the numbers. So usually we use functions to compute whatever you are looking for. And then if you change the data, you just change the data and run through everything works. So instead of 50, because we know already, we could have just done the state.x77. State.x77. And I can just run this to show you that will be 50. You get it? So, okay. And then what else? Replace, right? What will replace be?
True.
Good. So this should be true. Okay. Now, one way to do this, I can add this, is the probe. You see, I can assign probabilities to each religion. So for example, if I know that if you, let's say from past records, from let's say the census of US in, let's say, maybe 2010, maybe 70% are Christians, 10%, maybe 70%, 10% Muslims, maybe 5% atheists, and so forth. If I have that already, I can assign that probability to each of these. So that when we do it, it's like Christians will be selected more. Do you know what I'm saying? Yeah, so we can assign probabilities to it. It's just like when you are doing, it's like goodness of faith test or goodness of faith, yeah. So you know that in US, 70% of them are Christian. What we are doing, we are giving everybody an equal chance, every religion an equal chance of being selected. All the five. But you know that there is discrimination. Most of them are Christians. Then instead of that, we took probe. Then the first one, if it is Christian, we give it 0.7. The next one will be maybe 0.1. The next one 0.05, and so forth. So we can use the sample to do some medical statistician. You will be doing sampling. So these are the things you should master in. So when you are doing surveys and so forth, these are the sort of things you use. I should do. If you put everything together, then okay, so I can do this. Let's do this, then we see how this will look like. And remember, all of us will get different results, right? Okay, so if you do this, okay, we see that Christians are more well. We can rerun it again. Every time you do it, you get different results, unless you set seed. Okay. Was it only 2? Ah, okay. We can update religion, yeah. So let's update religion. We will add more atheists and other. Do they have traditional day? Okay. Okay, so what are we? Atheists. What else? You said traditional. Yeah, some will be Buddhist. Okay. We want to get 5. Okay. So we run this. What I'm saying is that if we do this, we can, so state, you see now we have Christians, Buddhists, and so forth. Okay. What I'm saying is that we can also add the probabilities. So let's say if we know that, let's say Christians, 70% are Christians, 8% are Muslims, then we get 0.78, right? Then 12, 0.12 are what do we call atheists? What else? Then traditional. So how many have we gotten? Now it will be 80, right? 80 or 90? It's 90, right? Because this will be 90, yeah. So then traditional is maybe 0.07, 0.0. And then the last one, 0.03. Okay. So there it is. So if we do this, then there is a high probability that most of them will be Christians. And you will not be surprised that, you see, most of the selected ones are all Christians. It's just like, you know, you come to this room and, yeah, you are checking the color of shirts people are wearing. So if most people are wearing black, you give them a higher chance of being selected. That's what we have done. Okay, let's move on. Now, what we can do is that I said we are going to do data frames. So I wanted to show you how the importance of data frames before we move on. Okay. So add relation to the population data, to the pop income data. Okay. You remember pop income? Yeah, so I can now check the structure of pop income. What can you say about pop income? If you look at the structure, it has 3 columns, yes. 50 rows. What data structure is it?
Numeric.
Yeah, numeric is a data type. So what is the structure? It's a matrix, good. Yeah. So it's a matrix made up of what? Numeric data types. Is everybody okay? All right. Now, what we want to do is that we want to add the religion on the side so that we have the, what is it? Population, income, illiteracy, and religion. Is everybody okay? Yeah. So pop income is like this. You see, then we are now going to add religion. So to do that, we call it new pop income. So to do that, we have what we call column bind using cbind. What we mean by cbind is column bind. So it means that take one column and attach it to another one. Right, okay. So we take pop income, and then what other thing are we adding to it? State or religion. So let's see what happens. So it does it. Now let's display it. What do you see on the console? It has added it. Is that the only observation? All of them have been 10 to characters. If you remember, I said that matrix contains what? Only one character. So when we are attaching using matrix, it will just change all of them to the lowest character in that data. So the best way to do this is to attach it as what? A data frame. Then we move from one to what? Multiple data types. Okay. So all data types are coerced. Where the coerced into characters. So the best form is to create a data frame. So to create a data frame, we use data.frame. So rather use a data frame. So to create a data frame, we use data frame like this. So we will call pop and state religion. And then we do it like this. Now, if I check this, you see, everything is done nicely. It preserves the structure of what? The data. So when we look at this, the first 3 columns are what? They are numeric. The last column, which is the fourth, is what? Is of character data. So that's a data frame. And most data sets in now are stored as what? Data frames. So please do this. Then we can now look at some of the practical data sets that we have as data frames in R.
Data frame, if you use a lower case, will it work? Or it should always be capital?
No. That's a name, so you can give it any name.
Yes, but can
Okay,
we use
you
them?
assign. Okay.
Yes, the assignment, that's up to you. Yeah, just that name it to reflect whatever you are doing. That's the only, yeah. Yes.
So we just did the new pop income. So in place of what you have there, can we use the new pop income?
It will override the previous one.
No, I'm not picturing what
You are not picturing. Okay. So whenever you have a name of an object and you run another one with the same name, it overrides the previous one.
Okay.
So what I have done now, I can also display pop income. But if I had used the same pop income to do this,
No. In the brackets where we have pop income and comma state religion.
yes. What are you saying?
So I'm saying that since pop income is the combine of those two, can we use just pop income in place of those two there?
The state X.
Yes, like.
Oh, because we were attaching it. If we take this one, new pop income, and we put it here, all of them will be characters.
Okay.
We can't change it. You cannot change a character into a number.
Data frame. So like my question is.
Yes.
You like if it's in a matrix and it's all characters, you cannot change from there to data
No,
frame.
you cannot
That's
change.
what I mean.
You can, but it will preserve it as
Characters still.
character still.
Okay.
Yeah.
That
In
makes
the case, to do it as a factor, but it can't change. You cannot change a non-numeric value to what? To numeric. Any question?
Yes, sir. The
Yeah.
state dot religion.
Yes.
The various religious groups that we
Sample.
sample.
Yeah.
Do we run that one first before we put in that function C by?
Yeah.
How to know that there exists state dot religion?
No, I did it. I generated it. It's here. There it is.
Okay.
Mm. Any question?
We are trying to generate.
So the next thing we want to do is that as for the subscripting is the same because they are all two-dimensional. Is that okay? It is the same. If I want rows, yes. I was calling you by your phone also. But Joseph, I sent Joseph. You've seen him. And so look for him. When you get him there, you bring me the receipt. Go to the TA as well. Yeah. Yeah. But I'm teaching you. Oh. So call, look for him and call him so that I can bring you the receipt. Okay.
Yes. We want to see your input for state of religion. We have,
oh no, we just, you don't, it's just a sample. We sampled, as I said, here it can be 50, but we just, to show you that you can find number of rows. It means that if you can also find number of columns, number of columns will be n call. Yeah. Then replace is true because we have only 5 religions. So if you want to be able to assign it to 50 states, then it means when you sample, you must replace. Because 2 states can have the same religion. Yeah. And then we were saying that there were more Christians in America, so we gave them 70%, and the rest, yeah. Okay. Okay. So for the subscripting, as I said, is the same. Yes. You couldn't come for the meeting.
No.
So I.
It's not
It's not.
too sharp. Or
It's a bit.
it's blur, a bit blur.
I think they see. So yeah. Around 30 something.
No.
So I was telling Luchi that. I'll finish this one before the next class. I'll send it to you. Any question? Okay, so subscripting with data frames is the same as that of matrices. It's the same as that of matrices. Okay, but we have an additional selection. Additional selection of variables. So in this case, it's only variables. You cannot select observations with that. So that you can use the $sign to do so. So for example, our data, that frame If I put the dollar sign here, it shows me all the variables. So if I want to get the religion of these people, these states, I just click on this, I can now retrieve it. If I want the income, there it is. Thank you. It was more than what I gave you. Oh. 100 cities. 10 cities. Thank you. Oh, okay. You can join. We have another one. We have another one. Okay. So that's what I'll add to this. So if you want to select a variable in a data frame, you just use a dollar sign. Okay. Now let me do the last one, which is the fourth, which is list. Remember that we said that a list is what? It's a one-dimensional array. A one-dimensional array. Array with that one-dimensional array that can contain. It can contain any data structure, including a list. So it can contain data structure, including a cell, as a list. So I want us to create our first list. All the data religion, we've done a matrix, right? We can put all of them in a list and display all of them. So we're going to do that. Yes. So my list. To create a list, we just use list like this. So list, is used to what? Create a list. Okay. So the first one, let's say I want to create a vector. So we have a vector. One of the vectors we created was what? Age, right? So I can call age. Then let's say vector numeric. I also want vector character. Vector CHR. So that one, the letters of the alphabet are also in R. So if you use letters, it will give you capital A, B, C, D up to Z. Okay. Then I need a matrix. So just to show you that it can contain any data structure, right? So what matrix did we have? Pop income, right? The pop income is a matrix. Data frame, I did not show you, but there is anorexia. Anorexia. And then what again? Data frame. Can I don't remember a list now, so we'll just end here. An example of a list that we could just add. But once I create this list, I can create another one with this one as part of it. Okay. So for us to do this, we please take mass, because the anorexia is in the mass package. So I'll show you the data we want to list in there. So anorexia. So just do question mark anorexia. It says what? It's in the mass package. Is anorexia data on what? Weight change. Okay. The anorexia data frame. So that's the data frame. It has 72 rows and what? 3 columns. So the columns are the variables. The weight change data for female anorexia data. So when you come here, the treatment, which is a factor of 3 levels, so I can actually display it here. So that's the data frame. So you have the treatment, pre-weight of the participant and what? Post-weight. All right, okay. So we can put all this into one list, right? So if we come here and we check our list, my list, it says it's 4. And if we do it like this, it shows us that my list, vector, it is double. You see, I was saying we have also double. So it is 28, 45, so then vector CHR is a character, 26, A, B, C, D. Matrix is double 50 by 3 if you write the pop density. Sorry, pop income. 3 columns. So this, that. And then data frame as this, 72 and so forth. Yeah, so if we display this on the screen, it will just occupy everywhere, right? So we can do it, and it's like that. So you see, that's the data frame for the anorexia. Okay, then it goes to the pop before the vector and what? Numeric. So that's a list. So the advantage of the list is that it can contain different data structures. So if you see the first one, the first data structure is just a vector. The next one is also a vector, different length. You cannot create a data frame in which one of them has more data than the other. The variables must have the same data in terms of the number or their size. And then we have this which has 3 columns and 50 rows. And then we have this one which has 3 columns by 72 rows. So they are different. Different data structures can be done in a list. So, but basically it's just like what? A vector. So if you look over here, use the data frame. We can also list if we want to subscript. Subscripting with list. So if I call my list, I can put the $ and all the objects in what? In the list will appear. So for example, if we want the matrix, if we want the data frame, what do? We click on it. Okay. And we can display it. Yes. I said you must take mass. The package is in package mass. So go to packages, take mass, then you have access to an array. No, when you have to click on mass. You haven't done packages. You have to go to packages. Yes. The anorexia data is in the mass package. So look for mass and take it. Just search for it. You just type over the mass. I mean, as soon as you start typing, then you take it. Take the box. The mouse cannot get there. If it cannot get there, you can type library mass. So now you can go and rerun the list. Are we okay? So that's how lists are also obtained. now we know all the data structures. Yeah.
I saw that increasing the
Yeah.
means
Yeah. Yeah. It has reorganized it. Yeah, so you see that place as reorganized, but one is not the substrate. Sorry, one is not it arranges it alphabetically, but the positions may differ. That's what I want to say. So, for example, you can retrieve the first. You can retrieve the first observation. If you put 1 in it, it won't be the data frame. Do you get what I'm saying? If not, maybe unless I demonstrate it. Let's see. You see here, if I come here, it says my list. So that's it. Vector, this, that. What else? Was that the question you were asking?
You see, we know the data frame.
Yes.
It's a data frame.
Yes.
We know that, but I'm seeing list here.
Yeah, it's because of the way it's stored, but it's a data frame. That's why its length value, it tells you that it's a data frame. It's S3 data frame.
So a data frame is a type of a list.
Not necessarily, but we can have a data frame under a list. But this one is already, you see, I can, maybe I should, just a moment, I'll add data frame 2. So I think we constructed the data frame. It's just that frame. Do you remember this one? Okay, so I'm adding that to my list. Then let's go here and check. You see, it looks at it like a list, but it will but this thing here we have now. The numbers come. What is all doing? Let's start at 10, 9, 8 until it gets to 1 there. So the last time. And this of the NF Abraham. We can bring it here. No one connected to here. And so I'm not sure it's the screen. Very weird. Okay. And yes, I say if I come up. Espinosa. Maybe I'm just going to come up. Yeah. You want to go? Okay, go.
If I can stay a little longer or something, if you have something else.
Tomorrow.
Like, no, I mean, for the whole period.
I don't understand what you're saying.
He wants to discuss something with you tomorrow.
Okay.
So what it is,
It's far. Okay, you can go. Okay. Tomorrow. Oh.
Thank you. Because that is
Okay. I'm saying this is so. This is so. I'm so. Okay. And how we'll see. I mean, you're in the class. Maybe I will try the web connect. I will say, then I will web. I will be connected to. projector, and so yeah. Then okay, Weber Street. This is so weird. It's evening time. Okay, so yes, so that's it with list. Yeah. So. Okay, okay, all right. Yeah, so that's it with list. The next thing is it's time, right? Or it's 5:30? 4:30. Okay, so I'm left with 3 minutes. So it's no more 4:30. Okay, so what we need to do is to be able to read data from Excel, test, and online from it. So I can show you, if you have a data in Excel, just go here, you go to import. This is for test. That is if you have it in Notepad. That's also good because it stores it. And then you can read from Excel as well. So all you have to do, put the data in your folder. You just click on this like that. Then you browse to where the data set is. I can read some to you. Let's say if there's Excel data, because you don't have it, you won't. Oh, the only one I have is results. Yeah, but okay, yeah, there's oh, let's see. I can show you some. I sent some. I'll send some. Do you have a page for your class? Yes, so maybe you should add me. I'll send you a data set over there. Then you can do this exercise. Okay. So let me see if I.
When I check mine, it's saying it requires updated versions of some packages.
Yeah, so you need to.
Packages.
You need to. So this is a data they use for up to 603. It's about live table. So I can, I think it's not, I can read that data because it's, oh no, this one is, what is it? It's not X, it's comma separated Excel. I want to, okay, let's say ticket sales. So ticket sales is a data, but that one is a test. So if I want to read it, I will just come here, but it's the same. Import data set from test, right? And then I go and look for it and so forth. So you just click on it and then it will come to, let me check 302 if I have some over here. Yeah, so you just double click on it. It will, unfortunately, I'm not getting where did I go to? I think it was active 6. Yeah, so ticket sales. So something like this, right? So it will come. I can change the name if I want to. If you don't want to, so it will come like this. It's the date and time. Remember I talked to you that we have dates variable, so data type variable. So the date, time, and then what, the count. So now we have this data in R, and you can check it. It's what's the name of the data? Ticket sales. So there it is. So that's 18,000. observations on or two variables. Okay, so this one data they use in one of my exams. And so I'll send you some. What we did not do, logical. So logicals are true or false. Maybe I'll talk about factors when we meet next week. Any question? Yes. If you have, come again. Yeah.